Okay, this video is for our differentiation in class practice number 15. And this one is going to be kind of long, so I might break this up into two videos. So this is the first one of two if I do decide to do that. So this is the problem. I said find the derivative of 2x plus 5 over x squared using the power rule, the quotient rule, and the product rule. So when I do this, I just wanted to show you that you sometimes have a choice, and when you get all done, they're all the same. Sometimes they don't look exactly the same. So we're going to do we'll do the power rule first. So I'm going to do the power rule first here. Let me erase that so it looks nicer. Okay, so the power rule. Okay, so the power rule is I'm going to take my original function f of x equals 2x plus 5 over x squared. And what we've been doing in class has been splitting that up and making it so it's in a form where I can do the power rule. So I have 2x divided by x squared plus 5 divided by x squared. And then I'm going to rewrite it like this. And that is a first power here, so this can cancel out. So I have a 2 over x. And I have plus 5 over x squared. It's almost there. Now I'm going to write it like in a form that I can actually do the power rule with. And that'll be 2x to the negative 1. I'm going to bring it up. Plus 5x to the negative 2. So this should be getting easier for you because we've been practicing this. Now I'm going to actually do the derivative. And the derivative, f prime of x, is going to be negative 2x to the negative 2 minus 10x to the negative 3. Now, prior to this, I had you rewrite this where you had positive exponents. But now what we're going to be working on is actually having everything written in factored form, and you'll see why later. So I'm actually going to write this in factored form. And this bothers some people because you want to take out the smallest or the greatest common factor of everything. So I'm going to actually take out a negative 2. And of the two, x to the negative 2 and x to the negative 3, the smallest one is x to the negative 3. So I'm going to take that out or factor that out. When I do, the first part comes out to be this divides to be a 1, and x to the negative 2 divided by x to the negative 3 have the same base. So you subtract, so that's going to be a positive x, or x to the first power. And then I'm going to divide, that turns positive, and then I have a 5, and that's what that comes out to be. So here I have the power rule, and that's what I got as the derivative in factored form. Okay? Now we're going to go back, and we're going to go back to our same function as f of x equals 2x plus 5 over x squared. Now this one also, we can use this with the product rule. Now if I'm going to use this with the product rule, I'm going to write it like this, x to the negative 2 times 2x plus 5. And we're going to use the product rule to complete this. So this is what we did in class. This is our f and our g. So I have two functions multiplied together. So my f is going to be x to the negative 2. My f prime is going to be negative 2x to the negative 3. G is 2x plus 5. G prime is just 2. So what I'm going to do now is actually throw them in the formula for the product rule. And the product rule formula is y prime is f prime g plus f g prime. So basically you kind of plug and chug. You actually just throw it right in there. And when I do that, I get f prime of x, because that's how it's written. This is just the actual rule for the product rule. F prime of x is going to equal f prime g, so I have equals negative 2x to the negative 3 times g, and it's plus, don't forget, this is plus f g prime, so that's going to be plus 2 times x to the negative 2. Okay? So we got f prime g plus f g prime. Now, this is what we did in class, so I'm going to kind of do a different color here. This is a term here, and this is a term here. So I'm going to factor out what they have in common. right? So this is what we do, f prime of g. I'm going to actually take out a -2 because I can. And if I look at this term here that's bracketed off and this term here, I can actually take out an x to the -3 out of both of those. So I'm going to do that. All right. So I have -2 x to the -3. Now what's left over? Well, if I divide all that, that's a 1. I just have a 2x plus 5 here. If I take and divide a 2 divided by -2, that's a -1, so it's minus. And this is a -3. This, again, it's the same thing. If I'm dividing x to the -2 and x to the -3, they have the same base. I subtract, and -2 minus a -3 is a positive 1. So that's x to the -1. So here I have f prime of x equals -2x to the -3, and that would be x plus 5. Again, if you look over here to the left, it's exactly the same as when we did the power rule. So this is the product rule. I should probably write that up here. So this is the product rule. So I use the product rule. All right. All right, now the last one, we can actually do this as a quotient as well. So I'm going to do this down here. I know we can't see it anymore, but I know you have your paper. So I have the quotient rule, and we'll see. They all should come out the same. All right, so here's the quotient rule with the same function. So I have f of x equals 2x plus 5 all over x squared. All right, now I'm going to do the quotient rule. So here's my f and here's my g. So I have f divided by g. Let's set it up. My f is 2x plus 5. My f prime is going to be just a 2. My g is x squared. My g prime is 2x. So I'm going to come over here to the right and do this. So I'm going to do, remember what the quotient rule is y prime equals f prime g minus f g prime all over g squared. All right, so that's our pattern. So we're just going to kind of plug and chug. Let me pick a different color here. So I've got f prime of x is going to be f prime g, so that's 2x squared, minus f g prime, so I'm just going to put the 2x in front of the 2x plus 5, all over g squared, so that's x squared squared, right? So let's kind of keep moving on this. So basically I've done the derivative, now it's working with the algebra. Now I wouldn't necessarily multiply this all out, even though in the past I have done that. So this is a term and this is a term. So I'm going to see what they both have in common. And since I pulled a -2 out of all of them, that's what I'm going to do with this one. So I've got f prime of x. We're going to go really slowly. I'm going to factor out a -2, and I can take out an x out of the top. What do I have left of this first term? As I have a -x right here, because 2x squared divided by negative 2x is -x right there. Then I'm dividing, so this turns positive. This is gone. And then I have 2x plus 5 all over x to the 4th. So I did that in different colors, so you can see if I take that, factor that out, I'm actually dividing each of those red brackets by -2x. All right, so let's go back to this. So I have f prime of x is going to equal -2x, and this is actually x plus 5 in this parentheses all over x to the 4th. And if we're going to look at doing this, I can say, oh, this is a factor, this is x to the 1st. I can cancel out and change that to a 3. So that's really -2 over x cubed times x plus 5, which doesn't look exactly like we did the other ones, but it's very similar because we had -2x to the -3, which is what this is. It's just written in the denominator. So here I just showed you where you can take one function and you can pick. Not all of them are like this. If you're going to do the power rule, the product rule or the quotient rule. All right, let's try this one more time. Okay, this next one, it says, this is number 2 on page 188. It says, find the derivative of the function in 2 ways, by using the quotient rule and by simplifying first. So when I say simplifying first, we're actually doing the power rule. So let's do the power rule on this one. And like I told the kids in class, if you can do it by the power rule and simplify, do that. And then you can look at doing it the other way. Now, on the quotient rule, I'm actually not going to do the quotient rule. It works, but there's so much more work to it, and it will match. I just showed you that it will. So we're going to do the power rule on this for practice. So I have f of x equals x to the 4th divided by x squared minus 5x cubed divided by x squared plus, I'm going to change that to x to the 1/2 divided by x squared. So I'm trying to get this all set up to do the power rule. So now that's x squared minus 5x. And here I actually look at this 2 as a 4 over 2, right? So 1/2 minus 4 over 2 is minus 3 over 2. Okay. Whoops, not there. What am I talking about? Sorry about that. Not there. It's the next one. All right, plus, sorry, x. And it is to the minus 3 over 2. Okay. Now I'm going to do f prime of x. And I'm looking at this right here. So I have 2x to the first power. All right. Then I have a minus 5. Then I have minus 3/2 x. And then I'm going to subtract 1. So think of that as negative 2 over 2 minus 5 over 2. And then I'm going to rewrite it. So f prime of x equals 2x minus 5 minus 3 over 2 radical x to the 5th. Now, you can do the quotient rule on this. It does work. If I were to show you my paper, it's like longer. But you end up this in the end. So I just want to let you know, if you can do it an easier way, please do it. The quotient rule does work, but it's a lot more work. Okay. All right, now we're going to practice doing some product and quotient rule problems, and these are right in the book, but I'm picking some to do that are practicing. So here's my F and G's. So this one right here, I look at it as a product. So I'm going to use my y prime is F prime G plus F G prime. Set up my F and G's right here. And then all I got to do is just plug them in. So a lot of people ask me, how do you want to write it here? Well, you can write it as x to the 1/2. Then when you do f prime, it's a 1/2 x to the negative 1/2. Okay. G is going to be e to the x, and I know the derivative of e to the x is itself. So this kind of helps you get all set up. And what I want to do next is actually plug it into this formula. So now I'm going to do g prime of x because that's what it was. G prime of x. So it's going to be f prime g. So I'm going to do a 1/2 x to the negative 1/2 e to the x plus f g prime. So I got x to the 1/2 e to the x. And literally right there is your derivative. But I want you to write it in factored form, very important. And I want to make sure that you're comfortable with that. But now I'm going to actually have you do something. So I have a term here and a term here. And actually, I'm going to have you factor out a 1/2 as well. So I'm going to take a 1/2 out, an x to the negative 1/2, and an e to the x out because they have that in common. When I do, I have a 1 plus, and there's like a 1 right here. 1 divided by 1/2 is 2. The e to the x is divided to make a 1. This is the same base, so if I subtract, it's going to be to the first power. So that would be what that would be factored. All right, so I'm going to stop this video right here, and I'm going to do the next 2 problems on another video so this doesn't make it too long. So hang on a second. Let me stop this one.